me record by myself. Yeah, I can record actually. Let's try to record. Can you?
Still, they still asking for the permission from the host.
There is no notification in here. I don't know why. Cannot find it. Okay, let's me find out later. Okay.
Okay, sir.
Okay, I'm going to start back again. You guys ready? Okay. Let me make this as presentation slides. Okay. Okay, this is adjusted cash flow at the time t divided by this. This is a same calculation as it used to be. So the difference between the adjusted model is only in here. Okay, your okay. If your risk is higher, then you can expect this expected return to be higher as well. Okay, if the risk, let's say, if the risk higher, you can put this as the probably 15%. Okay, your expected return. But if the risk is low, you can change this 15%, let's say, to become 10% or 9% or 8%. So if this value you adjusted, then it will change the value of the net present value. If it's higher, it could be negative. But if it's lower, then it could be positive. Remember that you can only accept the project only if the net present value is positive. If the net present value is negative, after you subtract your initial outlay, or let's say this is your invested money at the beginning of the project, then you don't have to accept this project if the net present value is minus, and is usually based on this. If this is higher, okay, then this value usually lower. If this is lower, this could be higher. Okay. So it will affect your net present value. Okay. So this is called adjust the discount rate. So you just simply adjust the discount rate, and then you can uh, know the result. The result sometimes could be positive when you adjust the expected return to be higher. Usually, the net present value is minus. But once you adjust to the lower expected return here, the K, then it will change the net present value to be positive. So this is the step how to calculate the risk-adjusted discount rate. The first step is simply adjust the discount rate for the K to reflect higher risk. High risk, high return, low risk, low return. Riskier project will use higher risk adjusted discount rate. And then you calculate net present value using the new risk adjusted discount rate. Okay, let me see this. This is only explanation in here. After this explanation, then I will show you how to calculate. I think this is enough for the next 14 minutes. Okay. The K with this is adjusted. So it means you can increase or you can decrease. How do we determine the appropriate risk-adjusted discount rate to use? Many firms will set up risk classes to categorize different types of the project. Okay, for example, like this. This is risk, and this is called risk-adjusted discount rate. RADR is risk-adjusted discount rate. Let's say class number 1, risk-adjusted discount rate is only 12%. For example, if you project type is only replace equipment, okay, replacing equipment or expand the current business. So your risk-adjusted discount rate is usually you can use 12%. class number 2, if you relate it to new product, okay? If your project related to the new product, okay, it will be higher risk because you don't know whether your product will be accepted into the market. So that's why you have to adjust the risk-adjusted discount rate to be higher compared to the class number 1, which is only just replace equipment or expand current without changing the new product. This is the new product. You know that some of the product that will be released by the company usually is not really customer don't want to buy the product, so you can use some of that. You can see at the market actually. So the class number 1, this is considered very higher. So that's why you have to adjust to become 16% here, which is higher than this. This is if your project type is unrelated new product. Let's say if your product, probably if you sell a truck and then suddenly you want to sell, I don't know, maybe medical product. Yeah, medical products now is really, the demand is higher for the medical product. And the last one is called, number 1 is project type is on research and development. So if your project is research and development, your risk is too high. Because in the research and development, you just spend money. You don't know whether you can find the new product or whether you don't know find on the new product. But usually in the pharmacy industry or in the drugs industry, if you find something, okay, let's say at this moment we have in the era that we have pandemic in COVID-19, you know, the coronavirus. If you, the pharmacy industry, and now if you have a research and development and you can find the vaccine for the virus, then I believe your company will get money, more money, you know. So that's in terms of research and development. But to find the virus like that is, you know, it's kind of hard, I think. There's a lot of company or even lots of countries trying to find the virus, the cure for the virus at this moment. They have initial outlay with $1 million and even billion US dollar in order to find the drugs for the coronavirus. So that's why this is considered as the higher risk. Whether you can find the product or not is depend on the process of the research development. Okay, that's from, okay, this is the summary of the recent budgeting, capital budgeting. Okay. Okay, this one. Okay, and then I have to move to, hold on. I have to stop this share. Oh, new share. This is a new share. Okay. This is an example of the certainty equivalent. Okay. Can you see this in Excel? Hello?
Yes, sir.
Yes, sir.
Okay. Okay, this is an example. Remember that we have two calculated in order to measure the project risk. The first one is called the first method is called certainty equivalent approach. So this is an example of certainty equivalent. So a firm with the 10%, let's say this is an example, a firm with the 10% of the required return is considering this new research facility with an expected life of 5 years. Okay, this is only for 5 years. the initial outlay associated with this project involve a certain cash outflow of 120,000 US dollar. So this is your first investment. Sometimes this is called a sink cost, but in here we call it as the initial outlay. The expected cash inflow, okay, this is outflow, this is inflow, and the certainty equivalent coefficient are as follow. Okay, we are trying to find the net present value here using this method, the certainty equivalent. If this is your initial outlay, then this is your expected cash flow. Okay, in the year 1, you expect to have a cash flow of 10,000. The year 2 is 20,000, and then it goes and on until the year of 5, you have 80,000. So remember that in this method, we actually have the coefficient of certainty equivalent factor. So based on this, the certainty equivalent coefficient, this is actually given, okay? Certainty equivalent factor at the alpha t, this is alpha, I don't know how to insert the symbol of alpha in here, so I just type in this as an alpha t. Okay, this is 0.95, the certainty, so you don't have a 100 certainty equivalent, sorry, you don't have 1 in here. Usually the coefficient will be less than 1. Because this one is risky cash flow. After the risky cash flow, you multiply with this coefficient, you will have the safe cash flow for your project. In this example, the risk-free rate of the interest is 6%. Let's say this is the time deposit as considered as the risk-free rate, or you can use the government bond, whatever you like it's actually, but both of them is actually considered as the risk-free. Sorry for the back sound. This is because of the work from home, school from home. Okay, the question in here, what is the project net present value? Okay, you calculate this net present value. To determine the net, this is the step. Okay, the first step. Okay, let's put it here. First step. The first step here. To determine the net present value of this project using the certainty equivalent, we must first remove the risk from the future cash flow. Okay. So we do by multiplying its expected cash flow by corresponding certainty equivalent coefficient, like this one. Okay. This is expected cash flow, this one. Okay. And then you multiply with this coefficient, then you will get the safe, or you can call it as the equivalent riskless cash flow. So there is no risk in here. This is almost certain that you will get this cash flow within the next 5 years. Hold on. This one, this is 2, this is 3, this is 4, this is 5. Okay, this is the year. Sorry. Okay. Okay. After you have this equivalent riskless cash flow, then you can move to here. Okay, the equivalent riskless cash flow are then discounted back. If this is number 1, this is 2. Okay, step 2. The equivalent riskless cash flow are then discounted back Okay, you discount it back to the present value as usual. Okay, if you want to, why you have to discount it back here? Because in this example or in the real life, you have to use the time value of money, or the TVM, time value of money. So that's why using the time value of money, then you have to discount it back to the present value, and there is less interest rate. So the risk-less interest rate is actually the 6% here. See, 6% is coming from here. This is the 6%. So you don't have to multiply with your expected return, which is the higher. Then it's rather for the safety, you just using the 6%. Riskless interest is not the firm required rate of return. The required rate of return will be used if this project has same level of risk as typical project for this firm. Okay. So, however, this equivalent cash flow have no risk at all. So this one you don't have any risk. So because this is consideration of what is so-called certainty equivalent method, and so that's why you use the 6%. This is considered as no risk. I cannot move this. Okay. So you don't use this 10%. Instead, you use only the 6%. So that's the explanation. However, okay, this is no risk, and then the appropriate discount rate is the riskless rate interest. The equivalent riskless cash flow can be discounted back to the present risk at 6% as follows. Okay, this is year one. This is, you get this, you just move this, all of this number into here, and then you use the present value in here. Present value factor of 6%. I use the table of, this is using the table of present value interest factor. Using the present value interest factor. Okay. This is your present value. So you just, oops, this is coming from F2, where's the F2? This is the equation. So you just want to probably. Okay. Functions probably. Okay. To find this, you just simply multiply this with this. Okay. I have to press function, forget, but this is as well. Okay. After you find the present value, then you get the NPV. To get the NPV, this is the calculation of the NPV. Function F2. Okay. So the present value, you just add this up. Okay. Your discounted present value, you just add this up, and then you subtract with this, the initial outlay. Remember, this 120,000 is coming from here. Okay, see? So that present value, you add this up, and then you subtract with this. This is equation, a simple equation in Excel. So actually, you can calculate NPV in here using the Excel as well. But this one, because this is manually, so I just use this. Okay, this is actually how to calculate the equivalent. So the difference between risk adjusted is only in here. Okay, you have this coefficient, and the risk adjusted, you don't have any coefficient. Okay, okay, this one is an example of the risk adjusted. Okay, how long we still have time for this? 3. Okay. This is, in this example, you don't have alpha, no alpha in here. Okay. So simply, this is your expected value, this is the year. Okay, this is an example of, you can just read this. A toy manufacturing is considered introduction of line of fishing equipment with expected life of 5 years. In the past, the firm has been quite conservative in its investment in new product, just sticking primary standard toys. In this context, the introduction of the line of fishing equipment considered as abnormally risky project. So this company is actually trying to get the abnormally risky project. So because they usually just producing this line, okay, and just producing toy, and then they change to the fishing line. In the theory, in the previous slide, this is considered as the unrelated new product. In here, the risk-adjusted discount rate will be 16% actually. But in here, it's actually 15%. Okay, managing the government required return of the firm's 10% is not sufficient. Instead, the minimum accepted rate. Okay, so in the risk-adjusted discount rate, is basically this is this. If you want to calculate, this is using the same calculation of the previous NPV that you learned from chapter 9. Okay. Remember chapter 9? So that calculation is the same. When you calculate the IRR and also you calculate the NPV. Okay, the equation is actually the same. You just free cash flow divided by 1 plus K and then minus initial outlay. Okay, or you can use the calculator for this. The only thing that, and also in here, the cash flow is the same. Every year they get the cash flow of 30,000. So the easiest way is actually you can use the calculator in here. This is, okay. This is an explanation of the previous discount. So what you need to do is you're discounting this annuity back to the 15% present yields, a present value of the future cash flow of this. Okay, if this 15 year, because the initial outlay is 110, so your net present value is minus 9,440. And if you use this 15% year, then you need to reject this net present value. But if the normal required return of 10% that you use, so you adjusted between 15% and 10%, has been used as the discount rate, then the project will have been accepted because the net present value is positive. So you just completely just make 2 calculations. The first calculation, you use this higher risk, and the second calculation you use the normal required rate of return, which is 10%. You just adjust this. If it's just the 10%, then you can accept this. Okay, that's the risk-adjusted calculation, discount rate. Certainty equivalent is adjusted. Okay. Okay, I have this question for you to practice. Okay, so try to practice this one. You can practice in here actually, because this is we are. Okay, if you done with this, then you can share. I think, can you share in here? Okay, let's practice this. After you practice this, after you finish this, then just let me know what is the result. Good job. Okay, since the remaining meeting time is 5 more minutes, so have you done with this to calculate this? Hello?
Hello, sir.
Not yet, sir. Not yet.
Yeah. I mean, I think the meeting is 5 minutes left from now. So I think you can submit to me the calculation, okay? Using my
Okay,
email.
sir.
So after this meeting is end, then the class will be end. It's only like 40 minutes time to. I think you have to. I just share something in your Telegram group. So please practice this. Let me share again. Okay. Please practice this, calculate this. If you done with this, then you can email to me, okay? All of you.
Okay, sir.
Okay, we have 31 participants in here. If it's not possible, because I recorded this, then I might send it to you. I'm trying to send it to you after this. So it's one more left. Okay, guys, I think I'm going to end up this session. So after this, please submit this to me. Okay, thank you. I'll
Okay.
see you
Yes, sir.
next week.
Thank you, sir.
Okay, see you, sir.
Thank you.
sir.
Thank you,
Yes,
sir.
sir.
Bye.
Thank you, sir.
Arigato, sir.
Okay.
Bye, sir.
Bye.
Bye, sir. Bye, sir.
Apa tuh?
Yeah, I have to end this meeting. Sorry about that.
Bye, sir.